All right, sorry about that, folks. There was a technical issue there. So um, what we have here then is basically a layout of what we have learned so far in this chapter. Okay, so first and foremost, we learned about what the mole is. The mole is just a unit, a number, unit that we can use to describe certain quantities of objects, these representative particles. Okay, and so with that said, then in this relationship here between moles and representative particles, we learn then that 1 mole is equal to this many particles. Okay. And so this is the conversion factor that we will use then to convert between mole unit and representative particles. Remember, representative particles then are the atoms, the molecules, the particles, particles, the formula units. So essentially all of the very small particles that we have to deal with in chemistry. So that's what these representative particles here. And so we can go ahead and we can convert between moles and representative particles, or go back in the other direction. We can flip that arrow around and go back in the other direction by taking advantage of this relationship right here. Okay. All right, then we went on, we talked about the relationship between the unit mole then and how much mass is this many particles will have. Okay. And so we refer to this as the molar mass, okay, which is the moles that is equal to the mass of a given substance. So here, we talked about the elements and the compounds. Okay, so these are the elements and compounds, the substances we talked about. The molar mass then for these elements, then we can get directly from the periodic table. So we can get that number from the periodic table. Okay, and remember, this ends up just being the molar, mass number for these elements in the periodic table. Okay, with the compounds though, we actually have to add together. Okay, we have to add the masses of each element in that compound itself. And so when we do that, we can get the molar mass and use that molar mass, which is the relationship between the moles, 1 mole, and I should specify here, and a certain mass. So it's 1 mole of a given substance and the mass equivalent to that. And the mass here, then remember, it's going to be in units of grams. Okay? And so we can use this relationship as a conversion factor to get from moles to mass, or we can flip that arrow around. And if we start out with mass, we can go back to moles. Okay. All right. Finally, then we have the relationship between moles and the volume. Okay. And now remember, this relationship here, for the most part, only holds when we have a gas. Okay. And that gas then is at STP. But when we do have a gas and the gas is at STP, we know then that 1 mole of that gas will occupy 22.4 liters worth of space. Sorry about that. So we can take advantage of that relationship in order to convert between moles and volume here. Okay, and so remember, this relationship here only, and I'm sorry, let me go ahead and erase this so let's clean it up a little bit. Okay, go ahead and erase this and put it down at the bottom here. Okay, so this relationship here, let me go ahead and start over. Sorry, folks. Okay. Okay. So this relationship here between the mole and this volume here, 22.4 liters, okay, this equivalent here we can use if and only if we are dealing with a gas at STP. Okay. So all of these here we can take advantage of and we can use in order to do the conversions. Okay, so the unit mole then is equivalent to that many particles, and we refer to that as Avogadro's number. Okay. And so the particles then will be these atoms, these ions, these molecules, these formula units that we've talked about. And so in this relationship here, and based upon this this diagram that I've given you, we can use that mole to convert between mass, convert to mass as well, and also volume. Okay, so keep this in mind. Hopefully write this down and on your own lecture notes, make sure you write this down and use this to help you study and understand then the relationship between the moles and each one of these quantities here. Okay, so we have counted quantities at the top here, which is what we talked about, the mass here and the volume. Okay, so they're all tied together by this unit mole. Okay. So what I'd like to do then is I want to go ahead and use each one of these conversions here. And so that's this is another slide that will help you see the relationship between the 4 types of conversions. The 4th one here is, remember, density to molar mass for a gas at STP. Remember, for this one, this only works for a gas, this conversion. at STP as well. Okay, so we know the density of a gas, we can find its molar mass if it's at STP, or vice versa. If we know the molar mass of the gas, we can also calculate for the density. So what you need to do when you go through these problems, then when you work through these problems here, first of all, identify, basically answer the three questions that we've been asking every time we do a conversion. What do you start out with? What do you want to end up with? What are the conversion factors that you need? In answering those three questions, then you'll be able to decide and determine then which one of these conversion factors, which one of these conversions you'll be doing. So what I'd like to do then is I want to go through and do a few of these problems with you, give you a chance to practice this, and I want to practice it with you. And then, like I said, at the end of this discussion, if you are still kind of unclear on how to go about doing these conversions here, stop by after school today from 3:15 to 4:15 and get your questions answered. Okay. All right. So let's go ahead. Let's start out with this problem here. So take a look at this problem. Take about a couple of minutes. If nothing else, make sure you set up the problem. Make sure you can identify what type of conversion it is, if you can. If not, then you're probably someone who probably should come see me after school today so I can help you. Okay. So at this point, then I think everyone should be able to identify what you start out with, what you're going to end up with, and what that conversion is going to be. Okay. And so let's go ahead, take a couple of minutes to set up this problem, and then I'll work it out with you. Okay. Okay. Let's go ahead and let's take a look at what we have here. So let's go ahead and identify what we start out with. Okay, so they're asking us about 1 mole of sucrose. So this is what we are given. This is what we are starting with. Okay, so we're starting with this amount of sucrose, and what they're asking for is the atoms, number of atoms in total here, okay, in that 1 mole of sucrose. So this is what we want to end up with. So if you notice here, this is just a moles to particles conversion. Therefore, we're going to use then the Avogadro's number in order to get that done. So let's go ahead then and write that out. So we have the 1 mole of sucrose, and this is the formula for sucrose, C12H22O11. Okay, and what we're trying to find here now, remember, be careful here, folks, is we're trying to find the total number of atoms in this many particles, of sucrose. Okay, all right, so the very first conversion factor, we need a conversion factor that gets us from moles to number of particles here, and that's Avogadro's number. So 1 mole of C12H22O11 is going to be equivalent to Avogadro's number, which is 6.02 times 10 to the 23rd particles of sucrose. Okay, so remember, the relationship here is between moles of sucrose and particles of sucrose, H22O11. Okay, so this substance has to be the same as this. The object here and the object here has to be the same. Okay, so therefore, if we're referring to sucrose here when we're talking about a mole, we're referring to sucrose here when we're talking about the total number of sucrose particles there are. Okay, so make sure you keep that in mind. And so if you notice, then this particular relationship, this equivalence, does not get us to atoms, and so we need a second conversion factor to get that done. And so what we do then is we have to count the total number of atoms in 1 particle of sucrose. So we have C12, H22O11, and in 1 particle of sucrose here, we have a total. So adding this all up, 12 plus 22 plus 11 gives us 45 total atoms. So there are the 2 equivalences that we need. This first one here has this unit in it, okay, which is what we'll need, and the second equivalence here, the second equality here, has the unit atoms here, which is what we also need. Okay, so we need both of these in order to get that done. Okay, so let's go ahead and let's plug in the first one. Okay, so we need to use the first one here. Why? Because we have moles of sucrose here. We have moles of sucrose here. So let's go and plug it in. So we have then 6.02 times 10 to the 23rd particles of C12H22O11 for every 1 mole of C12H22O11. This then takes care of that unit, okay? And so we have to convert now this unit here, C12H22O11 into atoms. We've already used this one, so don't reuse it. So we plug in the second one here so that we have then 1 particle of C12H22O11 is equal to 45 atoms. Okay, so that's what we have total. That unit there cancels out. We plug in our numbers in, and we end up with a number here that is 2.71 times 10 to the 25th atoms. And that, folks, is going to be our answer. Okay. So this very first conversion is just moles to particles. Now the particle here happens to be atoms. So we had to take an extra step here, but this is the first type of conversion that we talked about: moles into particles, and then we can reverse it, particles into moles. Okay. Very good. So make sure you write that down, folks, and get that done. What I'd like you to do is let's try another one. Do number 8 here. Okay, work this. Take a couple minutes. If nothing else, set up the problem, and then I'll work it out for you. Okay. All right, let me go ahead then. Let's take a look at what we have here. Okay, so let's identify what we have here first, and then I'll work it out for you on the next screen. Okay. So what are we starting out with? We're starting out with this amount, so 0.250 moles of each one of these substances here. So that's our starting amount. We are starting with moles. And what are we solving for here? We are calculating for the mass, and so we want to end up with mass, and it's going to be in grams. That's what we're going to end up with. This is then a moles to mass conversion. Okay, so we're going to do it, moles to mass conversion. So therefore, for each one of these, then we need the molar mass. Okay, so hopefully you can do that, folks. If you're not quite sure how to get the molar mass, please make sure you stop by and see me. Okay, so I'm going to write this down for you. So adding 12 carbons, 22 hydrogens, and 11 oxygens together, we have a molar mass here of 342 grams per mole. Okay. You have to make sure you get the formula for this correct, or else you won't get the correct molar mass. So the formula for sodium chloride is NaCl. And so the molar mass for sodium chloride then is going to be 56 grams per mole. And the potassium permanganate is going to be KMnO4. And if you add up 1 potassium, 1 manganese, and 4 oxygens, you're going to get a molar mass of 158 grams per mole. Okay, so these are all the molar masses here. So these are the molar masses that we'll have to use in our conversion. Those are our conversion factors. And again, how do we know those are conversion factors? Because we're starting out with moles, and we want to end up with mass. This is a moles to mass conversion, which means then we need the molar mass. Okay, so let's go ahead then, and let's please make sure you write that down. Let's go ahead and use those molar masses to do our conversion. Okay, so in each case then, in each one of these problems then, each one of these calculations, we're going to be starting out with 0.250 moles. Now the substance will be different, but the number will still be the same. So we start out with the very first one with conversion between 0.250 moles of sucrose, which is C12, H22O11, and we're going to convert that into grams of C12, H22O11. And again, the molar mass is what we're going to use here. And I gave that to you on the previous slide, and we're going to multiply by the molar mass, which is 342 grams of C12, H22O11 over 1 mole, C12, H22O11. You plug those numbers in, you get your answer here, then it's 85.5 grams of C12, H22O11. Okay. And so 3 significant figures here, because we started out with 3 significant figures here. Okay, let's go ahead and do the second one. Okay. Second one then, we start out with 0.250 moles of this time sodium chloride, NaCl. And we're going to go ahead and do the conversion here to grams of NaCl, sodium chloride. We're going to plug in the molar mass here, sodium chloride, which I gave you in the previous slide. It's being 56 grams per mole. Over 1 mole. Remember, these are all unit ratios, and so our denominator will always be 1. Okay, 1 in this case 1 mole of sodium chloride. You plug in those numbers in, and you get your answer. Then it's 14.6 grams of sodium chloride. Okay, and then finally for the last one, we start out with 0.250 moles of KMnO4. We want to find then the mass of equivalent to that, KMnO4. We're going to multiply again by the molar mass. This time the molar mass of KMnO4, it's going to be 158 grams. KMnO4 over 1 mole. Okay, MnO4. We plug in those numbers, we get our answer that is 39.5 grams. And again, in each case here, 3 significant figures, if we start out 3 significant figures there. Okay? And so this now is an example of a moles to mass conversion. So that's why we use the molar mass here. So at this point, then we've done 2 of the 4 types of conversions already. In the previous problem, we did the moles to particles. In this problem, we're going to do moles to mass. Okay, so what I'd like to do then is go ahead and try this problem here. So make sure then to do number 9 in your problem set, read what you were given, identify what you start out with, that is what you're given, and then identify what you're asked to solve for, and then choose the correct conversion factors to get that done. Okay, so let me ask you to take a couple of minutes to work out this problem as well, and then I'll work it out for you. Okay, go ahead and get started. Okay, let's go ahead then and let's take a look at what we have here. So for the very first one, what are we starting out with? We're starting out with 4.25 times 10 to the 24th molecules. So we're given the particles. We're given the number of particles that we're going to start out with. That's what we're starting out with, and we're trying to find moles. That's what we're going to end up with in this particular calculation. Okay, and for the second calculation here, we're starting out with 3.70 grams of boron. So we're starting out with mass here. So that's what we're starting out with. Okay, and again, we want to find moles. So we're doing 2 different types of conversions here. For the very first one, it's going to be particles to moles. For the second one, it's going to be grams mass to moles. So we were dealing with 2 of the 4 conversions here that we've done so far. So let's go ahead and let's take a look at these and let's work this out. Okay. All right, so for the very first one then, we're starting out with 4.25 times 10 to the 24th molecules of nitrogen dioxide. So I'll just write that as NO2, and we're trying to find here moles of NO2. And so here we will use Avogadro's number. Why? Because we have particles here. Okay, so therefore it's going to be 1 mole of NO2. That's going to be equal to 6.02 times 10 to the 23rd NO2 particles. That cancels this out. We divide these two, and again, make sure you can use your calculator to do this. We end up with a value of 7.06 moles of NO2. Okay, so that was the very first calculation. So again, moles of particles to moles this time. What we did in the previous problem is moles to particles. Back in for number 7, we did moles to particles. Here we're reversing it and we're doing particles to moles, but we're still using Avogadro's number. This time though, we're going to divide by Avogadro's number. Okay. All right. For the second one then, we start out with 3.70 times 10 to the minus 1. This time we have mass, grams of the element boron, and we want to find then the equivalent moles of boron. Okay, so this is a mass to mole conversion. Okay, and so unlike the previous problem, number 8 that we did, where we were given the moles and we're asked to solve for the masses, this time we're given the mass and we're going to need to solve for the moles. So we're going to use the molar mass still. We're going to use the molar mass of boron. This time we're going to divide by that molar mass. So how do we get the molar mass of boron? Go to the periodic table, find boron, and you end up with an and in my periodic table, I have 10.81 grams of boron. If you want to, you can round this to the nearest whole number, 11, but I just found this in my periodic table. And so I get then an answer that is going to be 3.42 times 10 to the minus 2 moles of boron. Okay. All right. All right, so what I would like you to do then, and to finish out here, I want you to take a look at numbers 10. Well, let's do this. 10 and 11 in your problem set. Okay, so I'd like you to finish up with numbers 10 and 11 in your problem set, work that out on your paper, and submit that by the end of the period. And then what I'll do is I'll start out with these 2 problems tomorrow. Okay, so please get numbers 10 and 11 in your problem set done, and then submit that on your paper here. Okay, so write that out on your paper and then submit that. And then I'll go over these 2 problems for you tomorrow. Okay, so I've run out of time. Hopefully I've given you enough time to finish up these 2 problems as well. So please make sure you try them. And then I'll start with these 2 problems tomorrow. Okay. All right, folks. Stop by after school today if you need that extra help. If you want to work out these 2 problems, you can save them and then come by after school and I'll work them out for you. Okay. All right. I'll see you folks either after school today or I'll see you tomorrow.